Hello, and welcome to the Ocean News Podcast, an audio series taking you through the biggest stories and the breaking news from the Oceanographic newsroom. I'm Rob Hutchins, news editor here at Oceanographic magazine, and in this episode, we'll be taking a deeper dive into a recently published study that has challenged all of our assumptions over who really is eating the long-spined sea urchin of the Australian east coast and why it really matters. There's a new turn of phrase emerging among the scientific community across New South Wales that goes, you can lead a horse to water, but you can't make a blue groper eat a long-spined sea urchin, no matter how much you may wish it to. Yes, surprising new evidence has emerged this past week casting new doubt over the long-held belief that large predators such as the blue groper and pink snapper are the primary control species of the long-spined sea urchin, a species that has been held mostly responsible for the spread of barrens outside the waters of New South Wales and into those of Victoria and more southerly regions of the Australian coast. It's an unexpected turn of events that could go some distance to shape new approaches to marine ecosystem understanding, presented in a study that has, since its publication in the scientific journal Estuaries and Coasts, done its best to subvert many an assumption. So let's start at the beginning. And to do that, we're going to need to talk to the author of the study himself, Jeremy Day, a PhD student at the University of Newcastle in Australia. Hi, Jeremy, and thank you so much for taking the time to talk with us here at the Ocean News Podcast. It's an absolute pleasure to talk with you, and I'm looking forward to learning your insight and to learning more about this study. So, shall we start then right from the very top and just talk about actually what the study was, first and foremost?
Yeah, certainly. So, I mean, the most recent study on blue groper and snapper potential to eat the long-spined urchin Centrostephanus rodgeri was basically based around the idea, the prevailing idea on this part of the coast that the reason why we have urchin barrens is because we don't have enough predators, right? And that's something that you see elsewhere in the world. I mean, you see it in lots of places where when you have an urchin barren, it can indicate that you've lost predators due to fishing or migration or all sorts of reasons. But there's only been a few people who've actually looked into this and quantified how often these predators actually eat Centrostephanus, the urchin in question. And our results from gut content suggested that it's not as often as you would think, which was really surprising. I mean, we actually started this study to look at the gut contents of these predators as a precursor to stable isotope analysis, which is, a different sort of way of looking at predator diets. But we had these really surprising results where, Centro wasn't present, or it was really, really, between 2 to 5% in these animals. And generally it's been thought that larger predators, because they're more capable of eating urchins, will do that. And you do see this when you tether urchins, which is, you surgically attach them to things and don't allow them to move around. When you serve them up on a platter like that, predators come and smash them. That's been extended to, the wild predation rates of predators when we don't actually know how often these things eat the urchin in question when they're left alone and, when humans don't interfere. So our results suggest that it's much less than is typically expected.
Okay, well, I mean, straight off the bat, that seems like a really interesting and significant find. So let's before we get into that, then let's take this right back even further to the very, very start. And could you just explain to us all what you mean when you say barrens and why studying the cause of them and the link to sea urchins is of such importance right now?
I suppose in New South Wales, it's mostly around community sentiment because barrens are a natural part of this coastline. In New South Wales, barrens, kelp habitats, and every habitat in between, like coralline flats and fringing reefs and all the rest of it, they work together to make a habitat mosaic. And barrens are a natural part of that for New South Wales. However, with the strengthening East Australian current and climate change, Centrostephanus has made its way further down the coast. So where I am in New South Wales, it's the natural range of these centro urchins. I mean, it seems to be business as usual, but further south, you've got these incursions of centro. They're creating new barrens in places they haven't been before, and
Right.
that's the problem. But
Yeah.
but for New South Wales, this has always been a part of our coastline. It's a native species, and basically, it seems to be that people, scientists included, have sort of seen all the work that's going on down south, which is trying to stem the tide of this Centra Stephanus larvae into Tasmania, into Victoria, into these new places. And, as a result, people have turned around and gone, hey, why isn't this happening on our part of the coastline? But the significance of our work is also that it's really difficult to determine the causes of barrens in terms of a lack of available predators to eat urchins
Mm.
and effects of climate change. Those things are really difficult to distinguish with our
Right.
quantitative data. So that's where I come in to try and provide some evidence.
I see. And so what has that evidence pointed towards then so far?
So it brings up a whole new range of questions, like if the predators aren't eating them, is this something that can or should be controlled? And by what right do you remove a native species? Now, because we've got this strengthening ESC, we've got this climate change happening, we've got this runaway climate model where
Mm.
barrens are increasing, predators have been overfished in the past, but presently, our predator stocks in New South Wales are going quite well, and the key thought to be the key predators like groper, snapper, lobsters are really well conserved in marine sanctuary zones and marine parks.
Yeah.
But in some places in New South Wales, where you have these marine parks that have been in place for over 20 years, in some places you actually see more barrens inside the marine park than outside.
Right.
And to scientists, that would suggest that this may be more of a natural habitat than a deleterious, crucial state that needs to be fixed by humans gardening the ocean.
Oh, I see. Right, the penny dropped. So we don't actually know if this is something to be concerned about, or this is just a part of a natural, like, as you say, habitat.
For New South Wales specifically, Centra Stephanus, its native home is New South Wales.
Yeah.
It's been here as long as we've known. The issue is that with the runaway climate model, it's reaching new places where it wasn't before. And
Yeah.
when Centra gets into new habitats, the evidence shows it's really difficult to remove. You've got this massive influx of lava just sort of constantly pumping down on the EAC.
Mm.
So, you know, we thought that the predators were going to be this really strong controlling mechanism. In my research to date on lobsters, snapper, groper, we haven't seen the controlling mechanism. And also, since longer than I've been doing science, we haven't seen the control occur in marine sanctuary zones, which elsewhere in the world, like Japan, Canada, America, New Zealand, Tasmania, when you make a marine sanctuary zone that's full of big predators,
Yeah.
you tend to get reduced barren and the kelp regrows. Whereas in New South Wales, we haven't seen that despite the abundance of many large predators.
Whoa. So that's just subverting assumptions left, right, and center then in that case. How has your perspective been changed then over the course of this study?
When I first came into this, I was quite sure that the blue groper was going to be this massive urchin predator that as it gets bigger, it controls urchins. And the reason why we have urchins must then be because we've run out of blue groper, or we've run out of big lobsters, or we've run out of big snapper.
Yeah.
But in places where those animals are abundant, we haven't seen that protective controlling mechanism, which everyone expected and which I also expected to see. But
Yeah, yeah.
it doesn't seem to have been the case on this part of the coast today.
Right. Begs the question, sort of, what's wrong with the Centrostephanus in the New South Wales area that they just don't have the taste for them?
Yeah,
Yeah.
that's a really interesting research question, which multiple people are looking into at the moment. But
Mm.
they've got much larger spines than many of the other urchin species, and we find both in the gut contents and in wild tethering trials and in caged feeding trials that that they generally seem to go for the ones with the smaller spines. And if they've got access to, say, something like a snail or a mussel, they prefer to eat that rather than centro. But the really interesting thing has been, even when we tested really big lobsters, it seemed to be the smaller lobsters actually were keener to tackle them. Not only can small lobsters tackle big urchins, they seem to do it more often. They seem to be keener to actually do it. So it's a kind of juxtaposition, because larger lobsters and larger predators are better urchin predators. They're better at doing it. And if you put them in a tank, they will eat more urchins. But
Yeah.
it doesn't seem to be reflected in the wild predation rates.
Maybe they see it as a rites of passage. The smallest lobster has to tackle the biggest urchin. Okay, that's a really interesting finding. You must have been surprised.
It's ruined me, because I came into this thinking I had an idea of what was going on, and yeah, it turns out that actually there's all this other fundamental work to do, which hasn't been done.
Yeah. Well, that's going to keep you busy for the next few years, I can imagine.
Some other clever person busy, I think, but
Okay, so what then, if any, conclusions can we start to draw from this study?
if I'm not throwing up too many conflicting models at once, it appears to be the predators don't eat the urchins we would like them to eat,
Hmm.
and the urchins eat all sorts of other things other than the kelp, which is being lost. So when kelp is removed, it's unsurprising that you find Centrostephanus in those areas. So if you were going on an observational basis, it's quite straightforward to say, hey, there was seaweed here before, there's no seaweed there now, and now there's urchins there. So maybe we need predators to eat these urchins. If we could just convince the predators to do what we expected them to do, the model would work. But it's
Sure.
unfortunately, ecology's
They're
not
not,
that simple.
they're not playing ball, right?
Exactly.
Okay, so what does the future then look like for this conversation? Where does your research go from here?
In terms of the way forward, I'm now working on stable isotopes, which is a non-visual method. I won't bore you too much with chemistry, but it's a non-visual method of looking at predator diets. So
Mm.
the important thing for gut contents is, some predators, like lobsters, as we found, can eat urchins without ingesting the identifying parts. Yeah. So while we have, a good ballpark sort of measure for how
Mm.
often these things are eaten, we need a concurrent lines of evidence approach.
Yeah,
Because there's no perfect experiment, but if you do all these different experiments and they sort of tend to line up in one direction, you may have an answer. So the gut contents of these fish, the gut contents of lobster, feeding trials with lobster, feathering experiments, that's all great, but the overall story is what we're really interested in. So
mm,
stable isotopes will provide another line of evidence for that story, and that's
mhm.
work that's currently being we're working towards publishing that soon.
Okay, cool. Oh, it'd be nice to stay on top of that then, and be across what those findings are when they come out. I guess the only real sort of conclusion that you can definitely draw, as with all of these studies, is that the marine ecosystem is way more nuanced and intricate than we really do understand right now, and that's why it's so crucial to keep pioneering and developing research and studying all these areas and findings. Yeah, they may lead to bigger questions, but that's taking you down a pathway to eventually maybe some level of understanding of these environments a bit better.
Yeah, I mean, absolutely. And our results suggest, overall that, the simplistic idea of, urchin bad, kelp good,
Mhm.
it's far more complex than that, because
Mm,
we've even found the lobsters to eat the macroalgae directly. So not only do they not eat the urchin we'd like them to eat as often as they do, they're actually eating the seaweed itself.
yeah.
So it becomes a cyclical model, that really, begs some more investigation by some clever people.
So if we were to package this up with one sort of message that you'd like this to convey to those worried about or concerned about conservation efforts, or in that frame, what would that be?
I'd say two things. I would say that ecology needs to be driven by biology, and presently we're still finding new things about the biology of these animals. The diet of centro, the diet of the predators which are supposed to eat centro. These are much more complex ideas than we initially considered. So we need to get that biology right,
Mm,
before we can start, expanding the virtues of the ecology, and offering answers when it seems like we don't even know what many of the questions are. It brings up a fundamental difference between, conservation biology, restoration, and ecology, right? So the two sort of points of view are, we don't have all the information, but we need to act right now.
Hmm.
Whereas the counter argument would be, you know, we need all the information before we act, which,
Yeah.
which makes it tricky because, it'd be great to have all these really easy answers and simple things. Like, for instance, if we just remove these urchins, that'll be great.
Problem.
And
Yeah.
and there's nothing wrong with removing urchins, and I'm interested to see how the industry goes running what I consider to be a large scale experiment. Of
Yeah.
course, I'm interested to see the outcome of that, but we're still finding out fundamental things about the biology of all of these animals,
Yeah.
which was thought to be sort of a cut and dry case, but it's not so simple.
Ah, well, Jeremy, you've completely opened my eyes to the nuance and the intricacies of these marine ecosystems. I've learned about the differences in the ecosystems, even on a very local basis, just from region to region in Australia. And you have indeed left me with more questions than answers, which I guess is always the point. Thank you so much for sharing your insights and your findings with us. If you'd like to learn more about sea urchins or our ever evolving understanding of the marine ecosystem in Australia and across the world, head to the Oceanographic Newsroom. This has been the Ocean News Podcast. I've been Rob Hutchins. Thank you for listening.